could reach out and touch its surface. This image, unveiled recently to gasps from astronomers worldwide, isn't just a picture. It's a window into a place that might, just might, hold the ingredients for life. But how did we capture this cosmic portrait? What does this planet bathed in the glow of its red dwarf star tell us about our place in the universe? Could it be a home for oceans, atmospheres, or even living things? Let's embark on a journey across the stars to unravel the mystery of Proxima B and explore what this discovery means for humanity's quest to find life beyond Earth. Picture a star, small and fiery, glowing with a ruddy hue against the velvet black of space. Proxima Centauri, a red dwarf, is no giant like our Sun. It's a cosmic lightweight, barely a tenth of the Sun's mass. Yet, it burns with a fierce energy that will outlast our star by trillions of years. Around this stellar ember, Proxima B wells in a tight orbit, completing a year in just 11.7 Earth days. Imagine that, a year shorter than a Netflix subscription. This planet is so close to its star, about 20 times closer than Earth is to the Sun, that it's locked in a celestial wall. One side basks eternally in starlight while the other shivers in endless night. This tidal locking paints a world of extremes where the boundary between day and night might be a twilight zone of possibility. A place where conditions could teeter on the edge of habitability. What makes Proxima B so tantalizing is its position in the habitable zone. The fabled Goldilocks region where it's not too hot, not too cold, but just right for liquid water to pull on a planet's surface. Water, as we know from Earth, is the elixir of life, the cradle for everything from microbes to whales. Proxima B receives about the same amount of energy from its star as Earth does from the Sun, sparking questions that keep astronomers up at night. Could this planet harbor seas that ripple under alien skies? Might it host an atmosphere that shields life from the harshness of space? Or is it a barren rock scorched by its star's tantrums? These questions aren't just scientific. They are deeply human, tugging at our innate curiosity about whether we're alone in the cosmos. The discovery of Proxima B itself is a triumph of human ingenuity. Back in 2016, astronomers using the radial velocity method, a technique as clever as it sounds, spotted this planet by watching its star wobble. Imagine a cosmic tug-of-war. As Proxima B orbits, its gravity nudges Proxima Centauri ever so slightly, making the star shift back and forth. This movement changes the star's light, stretching and compressing its spectral lines in a pattern called the Doppler shift. It's like hearing a siren change pitch as an ambulance zooms by. But instead of sound, astronomers track light to reveal a planet's presence. This method, honed over decades, confirmed that Proxima B exists, orbiting in the habitable zone of the closest star to our Sun. That revelation sent ripples through the scientific community, igniting dreams of studying a world so close yet so unreachable. Now enter the James Webb Space Telescope, humanity's most ambitious eye on the universe. Launched in December 2021 after years of anticipation, this golden marvel floats 1 million miles from Earth, perched at a cosmic vantage point called the L2 Lagrange point. Its 6.5 mirror, a mosaic of hexagonal panels, drinks in faint light from the farthest reaches of space. Unlike its predecessor, the Hubble Space Telescope, Webb is tuned to infrared light, the invisible glow that Proxima B emits as it reflects and absorbs its star's energy. This infrared vision is key because red dwarfs like Proxima Centauri shine brightest in this wavelength, and their planets do, too. When Webb turned its gaze to Proxima B, it didn't just see a blur. It captured a portrait so detailed it revealed hints of the planet's surface, perhaps even traces of an atmosphere. How did Webb pull off this feat? It's a story of precision and patience. The telescope's instruments, cooled to near absolute zero to avoid interference from their own heat, can detect the faintest whispers of light. For Proxima B, Webb likely used a technique called direct imaging, where it blocked the star's glare to focus on the planet's dim glow. This is no easy task. Imagine trying to spot a firefly next to a spotlight. Webb's coronagraph, a device that masks starlight, made this possible, while its infrared cameras teased out details invisible to other telescopes. The result, an image that's not just a scientific milestone, but a cultural one, a testament to what humans can achieve when we dare to look beyond our world. But what does this image tell us about Proxima B? The planet remains a puzzle wrapped in a mystery. Its position in the habitable zone is promising, but red dwarfs are temperamental. Proxima Centauri is a flare star prone to sudden bursts of energy that bathe its planets in ultraviolet and X-ray radiation. On Earth, our magnetic field and atmosphere shield us from the sun's outbursts. But Proxima B might not be so lucky. Its star's flares could strip away any atmosphere, leaving the planet as bare as the Moon. Even if an atmosphere clings to Proxima B, it might be a choking shroud like Venus with its runaway greenhouse effect rather than the breathable air we dream of. Scientists like Ed Turner at Princeton warned that habitability is more than just being in the right place. It's about having the right conditions, from a protective atmosphere to a stable climate. Water, the holy grail of astrobiology, is another open question. On Earth, water covers 70% of the surface, shaping life as we know it. For Proxima B, water could exist in many forms: vast oceans lapping at rocky shores, ice locked in the planet's dark side, or even hidden reservoirs beneath the surface like those on Jupiter's moon Europa. Webb's infrared data might hint at water's presence by detecting its spectral signature, a unique pattern in the light reflected from the planet. But confirming liquid water is a tall order, requiring not just advanced tech, but also a bit of cosmic luck. Some models suggest Proxima B could have a temperate region where water pools, especially in that twilight zone between eternal day and night. Others paint a grimmer picture, with water boiled away by stellar flares or frozen in inaccessible depths. Beyond water and atmospheres, Proxima B's very nature fascinates us. Is it a rocky world like Earth with mountains and valleys, or a gas-shrouded giant more akin to Neptune? Current data leans toward a rocky planet roughly 1.2 to 2 times Earth's mass, but we're still piecing together the clues. Its tidal locking adds another layer of intrigue. The day side might be a scorched desert, the night side a frozen wasteland, but the strip between them could be a haven, a place where temperatures allow life to take root. This idea of a habitable band fuels speculation, from microbial ecosystems to complex organisms adapted to a world of stark contrasts. Proxima B isn't alone in its cosmic neighborhood. It shares its star system with Proxima Centauri C, a larger planet farther out, and orbits within the Alpha Centauri system, a trio of stars that includes the brighter Alpha Centauri A and B. At 4.2 light-years, Proxima Centauri is our closest stellar neighbor, a red dwarf discovered in 1915 by Scottish astronomer Robert Innes. Its faint glow with an apparent magnitude of 11.13 hides it from the naked eye, but its proximity makes it a beacon for exploration. The Alpha Centauri system, with its 3 stars dancing in a gravitational ballet, reminds us that our cosmic backyard is alive with possibilities, each star potentially hosting worlds we've yet to discover. The discovery of Proxima B and its imaging by Webb mark a turning point in our search for exoplanets. With an estimated 206 trillion stars in the universe, the number of planets could be staggering. Some wander alone, rogue planets untethered to any star, while others, like Proxima B, orbit in systems as diverse as the galaxies themselves. Each exoplanet is a piece of the puzzle, helping us understand how planets form, how stars shape their worlds, and whether life is a cosmic fluke or a universal constant. Proxima B stands out not just for its proximity, but for what it represents, a chance to study a potentially habitable world up close, relatively speaking. What does this mean for the future? Proxima B is a siren call for exploration, but reaching it is a daunting challenge. A spacecraft like Voyager 2, plotting along at 34,000 miles per hour, would take 23,000 years to arrive. Yet, the dream persists. Concepts like Breakthrough Starshot, which envisions tiny laser-propelled probes, hint at a future where we could send emissaries to Proxima B within decades. For now, telescopes like Webb are our best tools, peeling back the layers of this distant world one photon at a time. Each observation brings us closer to answering the ultimate question: does life exist beyond Earth? As we gaze at Proxima B's image, we're not just seeing a planet. We're seeing ourselves reflected in the cosmos. This world, so close yet so alien, challenges us to rethink what's possible. It's a reminder that the universe is vast but not beyond our reach. Whether Proxima B is a lifeless rock or a cradle for life, it's a stepping stone, a spark that ignites our curiosity and drives us to explore. So, let's keep looking, keep dreaming, and keep chasing the light of distant worlds. The next discovery might just change everything. Whether Proxima B is a lifeless rock or a cradle of exotic biology, it symbolizes a threshold, a frontier not of mere distance, but of imagination. We stand at the precipice of a new era in astronomy where questions we once whispered into the night, are we alone? Is there another Earth? Can finally be approached with tools sharp enough to tease answers from the starlight. The detailed image captured by the James Webb Space Telescope may not show alien cities or forests swaying under alien winds, but it does show clarity, structure, potential, and presence. It gives researchers and dreamers alike a landmark to build upon. In university labs, data centers, and observatories across the world, astronomers are already picking apart every pixel of that image. They search for anomalies in the infrared spectrum, signs of methane, ozone, or oxygen, gases that on Earth suggest biological processes at work. If even a fraction of these biosignatures are found on Proxima B, it would send shockwaves through not just the scientific world but all of civilization. Imagine the implications of knowing that another planet a mere 4.2 light-years away carries the fingerprint of life. It would reshape religion, philosophy, science, and politics in one fell swoop. Yet with that potential comes caution. Scientists are deeply aware of the bias of Earth-centric thinking. We often assume life elsewhere must mimic life here, that it needs water, carbon, sunlight, and a Goldilocks zone. But what if life isn't Earth-like at all? What if it thrives in sulfuric atmospheres, feeds on radiation, or exists in states of matter we haven't even discovered? Proxima B, with its strange tidal dynamics and unknown composition, could be a laboratory for testing the limits of